Professor Wyman here, and I'm just going to show you how to make a repeated measures ANOVA table for your post hoc results. There are a lot of different ways to do this, and so I'm going to show you one example of how you can do this, but you can certainly do this a variety of different ways. So I'm going to start the way that I like to do it, and you can certainly edit this different ways, but you want to stick with this kind of general plan. So these are the results from Jamovi, just so I can refer to them. And I'm going to say table one. I'm going to give it a name. So post hoc comparisons for repeated measures. You could do this for a one-way ANOVA too. ANOVA comparing seconds spent on a Stroop task across three conditions. Man, I can't type today. There we go. So you want this to be, you can see that table one, you just want to, if you have multiple tables, you want to list them in order. So table one, I'm going to put that in bold. And then you have the title in title case, and I'm going to make that italics. And I'll go back and make this double spaced for APA style, but I'm going to go ahead and insert my table. So the way that I do this is I insert the table and I do all of the numbers first, and then I go back and edit the table itself. There are plenty of templates out there that you can certainly use. For me, I've just done this enough times that it's faster for me to make my own. And I think that a lot of you would benefit from doing that rather than using a template. But if you want to use a template, go for it. I don't care, whatever makes you happy, as long as it's correct. So I'm going to insert my table, and I'm going to do the time period is going to be my first column, and then the mean and standard deviation of each time period will be the next two. And then I'm going to compare exam 1, exam 2, and exam 3. So I'm going to go ahead and do a six columns, and I should have 5 rows. I can always change that. So first, I'm going to skip this first row, and I'm going to, in the second row, put time period or condition. It is time periods. I mean, you could do that too. It's just that they're condition names. And so condition 1 would be silence, and condition 2 would be classical music, and 3 is rock music. And then I'm going to put mean, standard deviation, and then this is going to be the conditions across the top as well. So silence, classical, and rock. This is all going to be left justified. This is going to be center. And actually all of this inside is going to be center justified. So I'm going to just go ahead and highlight all of this. I'm going to center it. And I'm going to, over here, I'm going to merge above the silence, classical, and rock. So you can select those and then right click and merge. And this is going to be where I put my Tukey's post hoc comparisons. You can call this different things, like you could say Tukey's post hoc p-values, but just use title case and center it. And then we're going to put in the numbers here. So for silence, again, I have this right here. Oh, I have the p-values here. Can't see it, but I have the mean and standard deviation for each of those conditions. And so I'm going to use that to go ahead and fill in the mean and standard deviation, because that way the descriptive statistics, we should really use that to understand what we're seeing. So silence would be a mean of 114.20. Classical, the mean is 160.09. And then rock is 138.66. For standard deviation, I'm going to do the same thing where I have the same number of numbers after the decimal because it's clean looking and it's organized and pretty. So standard deviation is going to be 58.01 for silence, 55.26 for classical, and then rock is going to be 48.09. So here, again, descriptively, this shows us that, and I have seconds up here, we can see that descriptively, the silence condition was faster than both of the other conditions. But according to our Tukey's post-hoc test, there's not a significant difference between silence and rock. And so that suggests that it's just sampling error that we found any difference there. So here, we're going to do silence. And what we're going to put here is actually the p-value. So this is going to be, and actually I'm going to change this. I'm going to say Tukey's post-hoc comparisons. Let's say Tukey's post-hoc p-values. So this is the p-value for silence and silence. I don't need that because that's the same variable. So this is like a correlation matrix. Same thing here. This right here is the p-value if I were comparing classical to classical. So I'm just going to put a little dash there, and for rock. And then I'm going to report the p-value for classical compared to silence right here. And for classical compared to silence, we're talking about this top line where our p-value is this 0.009. So I'm going to put 0.01. And then for rock music, silence and rock, that's this one right here, the second row. And so that's going to be p equals 0.16. And then classical, we're going to look at classical compared to rock, classical to rock, and that is going to be 0.22. Now you can do different things here. You could add a note. I like to add notes here, and I could say note. The overall model was significant. And then put in the notation here for the overall model, which is F with 2 degrees of freedom between, and there were 68 error degrees of freedom. Our F value was 5.86, and then P was less than 0.01. And eta squared, which I'm going to go to insert equation, and I'm going to use exponent, and I'm going to do my eta, which is this little long n. This is our effect size. Where are you, long n? There we go. There's the eta, and squared, and that equals 0.11. So this, I'm gonna fix up my APA style. So I want to italicize those numbers or those statistics. And I'm gonna make this all double spaced in just a second here. What's left is that I'm gonna highlight this whole table. And this is the way I do it. If you do it a different way, that's fine. Again, I don't care how you do it as long as it's correct. So for this, I'm going to go ahead and click to select all the borders. I'm going to make all of them white because I personally find that easier to work with. And then I'm going to highlight this top row here. And I'm again going to I'm going to just highlight the top part of it. So I'm going back to these borders. I'm going to highlight the top and make it black. And then the same thing here. I'm going to highlight the bottom, make this black. And oops, this one too. There's various ways to do this. This is just the way I'm doing it right now. But this is APA style to have no vertical lines, and then you just have horizontal lines to delineate between the rows of descriptors and then your actual statistics, and then have a row that's black at the bottom. The only thing I need to do now is I'm going to make my mean and standard deviation italicized. My decimals are lined up here, which is perfect. So I'm going to leave that as is. And then I'm going to highlight this whole thing and I'm going to double space it. There we go. That's an APA style table. If you want to, you can make this note, like you could click down on this note and add a space before paragraph if it's a little too close to your line here. But this is APA style. So then if I were writing out the results, I could say, please refer to table 1 for details on post hoc comparisons. And again, this could be a little bit different. This is just the basic format for how to present this information. And that is my last video on repeated measures ANOVA.